we start with what we call the right triangle definitions of the trig functions. Some textbooks do like a unit circle definition. It's all the same thing. So the first thing that you want to be comfortable with is from your background. If not, it's easy to review. It's just the Pythagorean Theorem. You do that all the time in trigonometry. It shows up constantly, right? So if you have a right triangle, we call the A and B, those are called the legs, and then C is the hypotenuse. And you don't have to write this down. I just want to kind of review some of this stuff. So the hypotenuse is always the side opposite the right angle, and then A and B are what we call the legs. The legs come together to make the right angle, okay? So A squared plus B squared equals C squared is how the sides relate to any right triangle, okay? We've known this for over 2,000 years. There's lots of proofs of this. Let me ask this question. One president proved the Pythagorean Theorem, and it's a unique proof. Do you know who that president was? Isn't the current guy, I'm pretty sure. It was James Garfield. He was a president in the 1800s, if I remember right. So he actually came up with his own proof, a unique proof. Einstein had a proof. There's hundreds of proofs of this. So kind of goes like this. What I was going to show you is this diagram is kind of like this. This is like, for instance, if you had this side was 3, that side was 4, that side would be 5. And the reason is because 3 squared plus 4 squared is equal to 5 squared. You don't need to write this down. You can if you want to. That would be 9 plus 16 is 25. So anytime the 3 sides of your right triangle are whole numbers, we call that a Pythagorean triple. 3, 4, 5 is a real common one. So what would happen, one way to help you understand the Pythagorean Theorem is you can think of this as area. So if you did the area of this square, that would be 9. If you did the area of this square, 4 times 4 is 16. And if you did the area of that square, 5 times 5 is 25. So actually, when you're doing the Pythagorean Theorem, you're kind of extending the area of squares on each side. Okay, that's what you're doing. And of course, A squared is an area, B squared is an area, and so is C squared. Okay, so that's what the Pythagorean Theorem's doing. So you're going to do this all the time in trig. Basically, we have what we call a Pythagorean triple. There's infinite things here. There's Pythagorean triples just means that the 3 sides of the triangle are whole numbers. Most of the time, that's not the case. Most of the time, one or more of the sides is irrational. It's like a square root. The 2 that I think you ought to memorize are these 2 right here, because these will pop up. It'll save you a little bit of time if you memorize 3, 4, 5, and 5, 12, 13. I think those are the only ones I even have memorized, but when I teach this class, I start remembering more of them. But there's like 8, 15, 17, and these other ones, and so forth. Another thing that's kind of good to know is you have families of these. So 3, 4, 5, if you doubled everything. So what I'm doing on this, if I double the sides, that would be 6, 8, 10. If I triple the sides, it would be 9, 12, 15. So there's an infinite number of Pythagorean triple families also, okay? So it's just worth knowing that, that sometimes you get 3 whole numbers that satisfy the sides of a triangle, but most of the time that's not the case, okay? All right, on the next page, you're going to just go through some definitions that you want to be familiar with. I'm just going to read these off. An acute angle just means the angle is between 0 and 90. We may have already talked about that a little bit. An obtuse angle means the angle's between 90 and 180. A right angle measures 90. Straight angle's 180 degrees. And then this will pop up in this section. Complementary angles add up to 90 degrees. Supplementary angles add up to 180. For example, 40 degrees and 50 degrees, what we are called complementary angles. 100 degrees and 80 degrees are supplementary angles. Those are things usually you learn in, earlier in school when you learn some basic geometry. Okay, so those are definitions that you need to be familiar with. Okay, now when we get into the trig functions, the way our textbook does this is they start by just looking at a right triangle and then getting the definitions of the 6 trigonometric functions. It turns out that if you have a triangle, and if you just write a ratio of the sides, there's 6 ways to do it. That's why we have 6 trigonometric functions. So in this diagram, if you look at this angle theta, then the side opposite is the side that's on the opposite side of the triangle. The side adjacent is next to the angle. Then the hypotenuse is always the longest side of the triangle, like that. So in a right triangle, you always want to know, in relation to your angle you're considering, what do we mean by opposite, adjacent, and hypotenuse? That's the key. And then the definitions go like this. So there's the sine of theta. What it is it's a ratio like this. It ends up just being, in this diagram, B over C. So in this case, it's the opposite over the hypotenuse. And you can write that down if you want to, but I think I've got that in that Sohcahtoa diagram anyway. Okay. The cosine is A over C. So what it is it's the side adjacent over the hypotenuse. So it's just a ratio of those particular 2 sides. The tangent is B over A. So that is the opposite over the adjacent, like that. All right, so that's what that is. It's just that particular ratio of the 2 sides in the triangle. Then we have the cosecant. The cosecant is just turning the sine upside down. So this would be the hypotenuse over the opposite. That's the definition. The secant is the reciprocal of the cosine. So it's going to be the hypotenuse over adjacent. And then the cotangent's the reciprocal of the tangent. So it is the adjacent over the opposite. So what you want to know, the best way, there's all kinds of ways you can teach students to memorize this. The most common is Sohcahtoa. If you have taken trig or pre-calc before, that's the most common way that teachers are going to tell you how to remember this. There's a couple other ways I've come up with and learned before. So it's just basically the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Okay, and you want to get this memorized because you will use it a lot. I'll never give you these definitions because you need to know this stuff. Okay, and then the other thing you need to know is the reciprocal of the sine is the cosecant, which we abbreviate CSC. The reciprocal of the cosine is the secant, which we abbreviate SEC. And then the reciprocal of the tangent is the cotangent, which we abbreviate COT, like that. Okay? So you want to know those 6 definitions and what they mean. So we're going to kind of start the section by getting comfortable with these ratios. And we don't really even do many applications in this section either. We just kind of get familiar with definitions. Okay? All right? One time years ago when I was kind of a beginning teacher, I challenged the class. I said, I'll give a contest to who comes up with a different way to remember this. So somebody came up with this one time. Instead of Sohcahtoa, I had a student come up with this. So he said, Oscar has a hairy old ass. So I've remembered that for years, okay? So that's another way to remember it. Whatever you come up with to help you remember that is fine with me, okay? Sohcahtoa is what I use most of the time. So I remember that, and the student told me that. Okay, so let's go to the next page, and what we're going to do with this is just write ratios on this primarily. So to begin with, you're given a right triangle. Now you don't know all the sides, so you're going to need to find what this side is. That's the hypotenuse, so that's C. So if you do a squared plus b squared is c squared, you're going to do Pythagorean Theorem, like I said, all the time in this class. So basically, a and b are interchangeable. It doesn't matter which one is 5 and which one's 12. So I just say 5 squared plus 12 squared equals c squared. That would be 25 plus 144 equals c squared. That's 169 equals c squared. Then I do the square root of both sides, so I get c is 13. So that hypotenuse is 13. Now that's what we call a Pythagorean triple. So I mean, if you know 5, 12, 13 and you were doing this problem, it'd save you a little time just to know that triple, okay? So we have that then. So what we're going to do is now that we know the 3 sides, we're just going to write the ratios out. So I'm going to go like this. The sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, and we're just going to look at this, and you just got to know what these things mean then. So sometimes a little easier to point on this. So you're looking at angle theta on this problem. You're not looking at that angle, okay? So basically opposite is 5, hypotenuse is 13. So the sine is going to be 5 over 13. You look at the cosine is adjacent, 12 over hypotenuse, so that's 12/13. And then the tangent is opposite over adjacent, so that's 5/12. You've got to just know what I mean by opposite, adjacent, and hypotenuse, okay? So the answer to the sine would be opposite 5 over hypotenuse 13. That's what that sine ratio is. The cosine is adjacent over hypotenuse, so that's 12 over 13, okay? And then the tangent is opposite over adjacent, so that would be 5 over 12 like that. So again, it just goes like that. That's the hypotenuse, that's the opposite, and then that's the adjacent, okay? And there, again, we're looking at that angle theta. We're not looking at the other angles, just that, okay? The other way to do this is the cosecant is just the reciprocal of the sine. So the cosecant would just be 13 over 5. If you know which ones are reciprocals, then once you get the sine, you automatically have the cosecant. Okay, same thing with the secant. The secant is the reciprocal of the cosine, so that's 13 over 12. And then the cotangent is the reciprocal of the tangent, so that's 12 over 5. Okay, like that. So that's all you're doing to start on this is just, if you have a triangle, you want to be able to go through and write those ratios. Okay, everybody with me there? Okay? Okay? All right. So with this one, we got to find this missing side. So this, of course, would be C. That's the hypotenuse. This one's A or B. It doesn't matter. It's up to you. I'm just going to call that A. And then we're going to do the Pythagorean Theorem. A squared plus B squared equals C squared. I'm just given a triangle with a missing side just to go over Pythagorean Theorem a little bit. Okay, so what I would have is A is 2, so that would be 2 squared. B is this side, the missing side, so that's B squared. C is 4. So we need to solve that equation and find what that side B is then. Okay, so far, you were given those two sides. So this would be 4 plus B squared equals 16. You can subtract 4 from both sides, and you would end up getting B squared equals 12. Okay, then you would square root both sides, so you get B is equal square root of 12. Okay, now one background issue that shows up in trig a lot is square roots. You'll deal with square roots for the rest of the semester. They show up everywhere in trigonometry. So you have to know how to simplify things. When we've reviewed this before, so you would break that up into 4 times 3. So you would get 2 radical 3, and you want to always simplify stuff when you do this. So that means that the missing side is 2 root 3 like that. So now we've got all of the sides of that right triangle. Okay, everybody with me there on what I did? Okay, because we're going to have to reduce and rationalize denominators too quite a bit when you're learning this then. Okay, so again, let's just start with the sine, cosine, and the tangent and get those put together. Okay, now see what happens now is everything kind of changes. We're looking at this angle theta, so opposite is going to be this side, adjacent is going to be this side, and then the hypotenuse is always the hypotenuse. So you got to focus on the angle to know the difference between opposite and adjacent. So, okay, so now it's actually real easy to do. So the sine would be opposite, which is 2 root 3, over hypotenuse, which is 4, and then you could just reduce that fraction. So 2/4 reduces to 1/2. So after you reduce that down to 1/2, you're going to end up getting the square root of 3 over 2. So that would be the answer to what the sine is. Okay, like that. Okay. The cosine is adjacent over hypotenuse. So adjacent is 2. Hypotenuse is 4. Well, that would reduce to 1/2. So you would have that would be your cosine ratio then. Okay. The tangent is opposite over adjacent. So opposite theta would be 2 root 3. Adjacent would be 2. The 2's cross out, so you would end up getting the tangent ratio is just 1 over, is square root of 3. Okay, is everybody with me there, what I did? Okay, let's just basically look at the angle, because you can talk out what opposite, adjacent, and hypotenuse is, and then you formulate the ratios, and then you got to do whatever algebra you have to do on this then. Okay, so what I'm going to do on this now is I'm just going to turn these upside down. So the cosecant would be 2 over root 3, but we're going to rationalize the denominator. You're going to rationalize denominators throughout the semester here. So what you typically always do is you don't want a square root in the denominator, so you multiply both the top and the bottom by that radical to get rid of it. Okay, and what you would end up having is you would have 2 radical 3 over square root of 9. And you don't have to do that. You can rationalize in your head. You will generally do that so much in this class that you'll just always do this in your head. Okay, so that's your rationalized answer to the cosecant. Okay, so we have that. All right. Then the secant is the reciprocal of the cosine, so that's 2 over 1. So that would just be 2. Okay, and then the cotangent is going to be the reciprocal of the tangent, so that's 1 over square root of 3, like that. And then you want to rationalize that denominator, so you do the same thing. You multiply by square root of 3 over square root of 3. Okay. Again, you can do this in your head. That would be square root of 3 over square root of 9. Therefore, that's square root of 3 over 3, like that. Okay, so you're going to deal in this class a lot with square roots. They show up all over the place in trigonometry because of the fact that we're dealing with right triangles. Okay, that's the idea. Okay. All right, everybody okay with what I did? And understand the difference between opposite and adjacent and hypotenuse. That's the key. And then know your definitions and then how to put that together. Okay, so I'm going to go ahead and just let you do one of these. Go ahead and just do this one yourself. And you need to start by finding C. And you'll have a square root on this. I wanted to just have you do one in class where you have a square root. And then I'll write down the definitions. I'll just give you a few minutes to see if you can put these together. But make sure you get your definitions down. And one thing I'll say about trigonometry, there's a lot of formulas and things you have to memorize. A lot more than you did the first half of the semester. There's going to be a lot of stuff you memorize. But I'll try as much as I can to teach you, how to develop things. But definitions are definitions. You just have to know them. And you'll have, I think, some whole numbers in some of this, and some of the ratios will be whole numbers, and some of them will have a square root of 2 in them. Right? This is actually a 45-45 right triangle is what it is, which we're going to talk about mostly next week. Now, what I got on C was I got the square root of 18, so you should have got to that point where you got square root of 18, and then I broke up the 18 into 9 times 2, not 6 times 3. 6 times 3 doesn't do you any good. Square root of 9 is 3, so you're looking for a perfect square factor. So you've got everything set up, and we're looking at angle theta, so opposite is 3, adjacent's 3, hypotenuse is 3 root 2. So now it's a matter of just putting it together. So the sine would be opposite 3 over hypotenuse, 3 root 2. The 3's would cross out, so you would end up with 1 over root 2, and then we'd rationalize that. Now, what I would do on this is I'd go ahead and just get the cosecant now. I would just go ahead and turn that upside down and get square root of 2 over 1. So the answer to the cosecant would be best written as square root of 2. Okay? Then I'm going to go through and I'm going to rationalize the sine. So I'm going to multiply by root 2 over root 2. The answer you would get on the sine is square root of 2 over 2, like that. Okay? And students usually, but you do this so much in trig, you'll be to a point where you'll have no problem rationalizing and dealing with this because it's just a common skill we do. Okay? All right, the cosine, you should have got the same answer. On the cosine, it worked out this way. The cosine is adjacent, which is 3, over hypotenuse, which is 3 root 2. So that's just 1 over root 2. It's the same thing we got for the sine. So that's root 2 over 2. Okay? Since the sine and cosine are the same, that means that you're going to get the same answer on the secant. So that's going to be root 2 like that. So you don't have to go through all the details on the cosine and then the secant. Okay? All right, the tangent is opposite, which is 3, over adjacent, which is 3, so you get 1. Okay, you get that. And then the cotangent's adjacent 3 over opposite 1, or 3, so you also get 1. Okay, so those are the ratios that you get on that. And once you get the 3 sides of that triangle, you just apply the definitions, you rationalize the denominator as you need to. Okay, if you remember sine, cosine, and tangent, the Sohcahtoa, that's good enough, and then just know how to do the reciprocals, then you got it. Okay, that's it. All right, everybody okay so far? Okay, all right. Okay, so that's going to be kind of enough of that. Now what we're going to do next is, and part of the purpose of this is to help you understand your definitions on this next page. So the idea is, it turns out that if I give you a trig function, then that's all it takes to find out the rest. You only got to know one trig function to find the rest. And now what we're going to be talking about in here is we're going to be talking about acute angles. Okay, so this angle theta is an acute angle, which means it's between 0 and 90. This problem's a little bit different if that angle is not an acute angle. There's more considerations to make. So we're between 0 and 90. Right now we're just thinking about that angle theta is one of the other 2 angles in a right triangle. It's not the 90-degree angle, it's the other angle. Okay? So here's the way I would do this problem. Okay? First of all, the sine by definition is opposite over hypotenuse. And you're going to find this is going to turn out to be exactly the same thing as what we just did. Okay? So I'm going to draw a right triangle. You can kind of draw it however you want to. So I'm going to just say, okay, that's my angle theta. You could also have the top as angle theta. That's your decision. But what you would have is you would have, this would be opposite, this would be adjacent, and then that would be the hypotenuse. Okay, so in this particular problem, what you're given is you're given the side opposite is 1, you're given the hypotenuse is 3, so that means you need to find the side adjacent to find the rest of this stuff then. Okay, so I'm just going to do that over at the side. I'm going to do the Pythagorean Theorem to find that missing side. Okay, and remember, A and B are interchangeable, so I'm just going to say that A is 1, and the C is the hypotenuse, so that's 3. So what I'm going to get is 1 to the second plus B to the second equals 3 to the second. I'm going to work out the details, so that's 1 plus B squared equals 9. Subtract 1 from both sides. That's going to give B squared equals 8. Okay, I tried to pick some problems in class where you have to work with the radicals a little bit, because that's a background issue you may have to address. How do you break up 8? You break it up into 4 times 2. So you would write that as 2 root 2. Okay, so what we end up getting then, and now the rest of this problem is going to be the same as what we did on the previous page, is we now know the 3 sides of our triangle, so now we can easily find the ratios. Okay? So that's Pythagorean Theorem. Anytime you're given any 2 sides of the right triangle, you have the ability to find the exact answer to the other side. Okay? Now we just start putting this together. So the sine is opposite over hypotenuse, so that would be 1/3. I already gave you that in that problem. The cosecant is the reciprocal of this, so that would just be 3 over 1, or just 3. Okay, so we got that. If you know the sine, then you turn it upside down to get the cosecant. Okay, the cosine is the adjacent over hypotenuse. So the side adjacent in this diagram is 2 root 2. The hypotenuse is 3. That's rationalized, so that's good enough. Okay, that's done. That's your exact answer to your cosine. Okay, the secant is the reciprocal of the cosine. So if you turn it upside down, you would end up having 3 over 2 root 2. And then you got to rationalize the denominator. So if you want to get rid of that square root of 2, then you just multiply both the top and the bottom by square root of 2. Okay, what that's going to give you is 3 root 2 over 2 times 2. Okay, because see, this part right here is really the square root of 4, so it's 2. So you would end up with this. You would have 3 root 2 over 4 would be your answer to the secant then, if you rationalize that correctly. Okay, just always multiply by whatever square root you're trying to eliminate from the denominator. Okay, and then the tangent is opposite over adjacent. So in my diagram, opposite is 1, adjacent is 2 root 2, and you'll have to rationalize it. Now I'm going to go ahead and turn it upside down now for the cotangent. So the cotangent is 2 root 2 over 1, so that would just be 2 root 2. So that gives the cotangent, and then I just rationalize the denominator on the tangent by multiplying by square root of 2 over 2. Okay, so that would end up giving square root of 2 over 4. You work out the details on that. Okay, so that would be your ratio on that problem. Okay, so again, if I give you a trig function, I've basically given you 2 of the 3 parts of the triangle, the hypotenuse, opposite, and adjacent. You can find the third part with Pythagorean Theorem, and once you do, you apply your definitions. Is everybody with me there so far? Okay, it's all about, this is exercises to get you comfortable with definitions, okay, and triangles and Pythagorean Theorem. Okay, next thing, what we're going to do, now we need to put the 2 over 1, and the definition of the cotangent is, it is the adjacent over the opposite. So you know the adjacent and you know the opposite, okay? So I'm going to take the same approach. I'm just going to draw a triangle. It's a right triangle. I'm going to call that theta, okay, that base angle. Adjacent would be this. Opposite would be this. Hypotenuse would be that, okay? So what I've given you in this problem then is I've given you the adjacent is 2, and I've given you the opposite is 1, so we need to find the hypotenuse. So we need to find what C is, okay? And I'm going to do this just at the sides, so I've got a squared plus b squared equals c squared. So a and b are 1 and 2. They're interchangeable. A and b are the legs. So I'd have 1 squared plus 2 squared equals c squared. So that's 1 plus 4 equals c squared. Square root of both sides, what you're going to end up having is c is the square root of 5. Okay, so I'm just going to tack that in as square root of 5. So my sides are 1, 2, and square root of 5. Okay, now I just put together the definitions, and I got it made. Okay, so the sine is opposite over hypotenuse. So opposite is 1. Hypotenuse is root 5. I'm going to do the rationalizing at the end of this problem this time. The cosecant would just be root 5 over 1. So that's root 5. And we'll go back and rationalize next here. All right, so if I multiply by root 5 over 5 there, I'm going to get the sine is going to be root 5 over 5. And then the cosecant's root 5. Okay, like that. Okay, the cosine is adjacent over hypotenuse. So adjacent is 2. Hypotenuse is root 5. Okay, turn it upside down to get the secant. So the secant would just be root 5 over 2. And then we need to go back and rationalize the cosine. Okay, so if I do this, multiply by root 5 over root 5. So that would give 2 root 5 over 5 when you get that down. Okay, so that's what we have. And then finally, the tangent is opposite over adjacent. Opposite is 1. Adjacent is 2. So we have that. And then we already had the cotangent. I gave you the cotangent. Okay, so that is 2 anyway when you do the reciprocal. Okay, and that's it. Okay, so what you want to make sure you understand is if I give you a trig function, then you know 2 of the 3 parts of the triangle. And then since you know the definitions of Pythagorean Theorem, you can figure out the rest. Okay? All right, let's go ahead and do this one. Go ahead, I'm going to let you start this one. Let's just kind of do the first part together. The definition of the cosine, remember Sohcahtoa, would be adjacent over hypotenuse. Okay, so the adjacent is going to be this side, 3. Hypotenuse is 5. Do you guys already know what that other side is? Remember, there's a Pythagorean triple. This is one of the ones you want to remember. Do you remember? 4. Okay, all right. If you don't know that, you go to the Pythagorean theorem. So go ahead and now finish up the rest. This is an easier problem than the ones I did because there's no rationalizing in it. So go ahead and just see if you can figure out the rest then. I'll put the definitions up here. So let's see, the sine in this would be, and it's going to go like this. This is going to be opposite theta. This is going to be adjacent. That's going to be hypotenuse. Sometimes students get those things mixed up. So the sine is just going to be 4/5. Therefore, the secant is going to be 5/4. The cosine was already given as 3/5. Therefore, the secant is 5/3. The tangent is opposite over adjacent, so that's 4/3. Then the cotangent is the reciprocal, so it's 3/4. That's it. Okay, if there's no rationalizing, there's nothing to do except just apply your definitions. Reduce fractions, that's it. Okay, any questions so far? Okay, let's finish up with just one other thing. I'm going to talk a little bit about cofunctions and what this means. And this type of thing right here, you're going to notice that we have the word co. The prefix co means something in trigonometry. You have the sine, you have the cosine, the secant, cosecant, tangent, cotangent. They're called cofunctions of each other. And cofunctions kind of have a special relationship to them in a triangle, okay? So the idea is, and you don't have to memorize it because it's built in to the definition, okay? So the relation goes like this. There's a couple of things I want to run through and remind you of. 2 angles are complementary if the sum of the 2 angles is 90 degrees. So anytime 2 angles add up to 90, they're called complementary angles. Okay? So if I ask you what's the complement of 10, what do you add to 10 to get 90? Well, it's 80, right? So 80 and 10 are complements. What's the complement of 60? 30. Okay, right? What's the complement of x? Now we're generalizing. Good, 90 minus x, okay? I mean, because what you're doing is if you find, I mean, you could do those first 2 problems in your head, but if you do 90 minus 60, so you get 30. And on this first problem, if you do 90 minus 10, you get 80. So that's how you find a complement, as you subtract from 90. That's the idea, okay? All right, let's go through this, this diagram here, then I'll just talk. I think we can kind of develop the idea of how cofunctions work with complementary angles. Now, what I went ahead and did on this problem, this is a triangle that we'll be talking about next week. This is a 30-60 right triangle. The sides can be reduced to this. I'm just given those. I'm not ready to show you where that comes from yet. But what we're going to do in this diagram is we're just going to start by finding the sine of A. So the sine of A is opposite over hypotenuse. So this angle A is 30 degrees. So opposite 30 is 1. The hypotenuse is 2. So the sine of A is 1/2. Okay? Now what we're going to do is we're going to go to the cosine, not of A, but of B. Okay? So the cosine is adjacent over hypotenuse. Okay? So if you look at this angle B, the adjacent is 1. The hypotenuse is still 2. So they turned out to have the same answer. And the reason is because the sine and the cosine are cofunctions, and 30 plus 60 is 90. They're complementary angles. So that's what you're going to find is if you do the sine of an angle and the cosine of its complement, you're going to get the same answer. You always will. Now I'm going to do this with the other trig definitions also. The secant is hypotenuse over adjacent. So in this diagram, and again, we're looking at angle A right now, the hypotenuse is 2. The adjacent is square root of 3. Okay, because we're looking at angles. So it's hypotenuse over adjacent. Now I'm going to do the cosecant of B, and the cosecant's hypotenuse over opposite. So if you look at angle B now, hypotenuse is 2, opposite is square root of 3. So notice you get the same answer again, and the reason is because secant and cosecant are cofunctions. Okay, so anytime you do those, the secant of A, the cosecant of the other acute angle in a right triangle, you get the same answer. Okay, so it works on tangent and cotangent also. The tangent is opposite over adjacent. So if you look at angle A, opposite angle A is 1. Adjacent is root 3. Okay, now don't worry about rationalizing denominators. I don't care about that in this problem. I'm just trying to prove to you that you get the same answer. That's the point. Okay, so the cotangent of B, the cotangent is adjacent over opposite. So if you look at angle B, adjacent would be 1. Opposite angle B would be square root of 3. Okay, so you get the same answer on that. That's the idea. That's what cofunctions are. That's the idea. Now I'm going to finish up here with just one little quick thing. It only takes a minute to kind of explain. And down on this thing here, I just took this out of the book. See, this is what will always happen. Like sine of 30 and cosine of 60 are the same answer. And the reason is the angles, the trig functions are cofunctions, and then the angles are complements. Same thing here, tangent of 40, cotangent of 50. You have cofunctions, you have complementary angles. Same thing with secant of 80, cosecant of 10. That's the idea. Okay, you're always going to get the same answer. Okay? All right, that's probably a good stopping point then, and then we'll wrap this up next time. Be sure you go on to Canvas because I've got all kind of some updates and stuff to look at. Okay?